right. Well, it is good to see everybody. Hope you're having a good day so far. Our plan today, I want to talk about graphing the rational functions first. We'll talk about that assignment. Probably do one or two questions or more if necessary, because we have that quiz tomorrow. And then once we finish up with the rational functions, we'll go ahead and look back at rational equations, what we started yesterday with proportions, and we'll get into LCDs. And then hopefully by the end of the week, we should be starting variation, but we'll kind of see how that plays out. But any questions about what's happening? So this is the first thing we need. Okay. So this is what the homework looked like. Number one was x plus 3 over x minus 2. Did anybody need a copy of this? Okay. Take a look through my list in here. Okay, graphing rational functions. Okay. Anybody else need a copy? There we go. Okay. All right. Well, let's take a look. I mean, we can just go ahead and start with number one, or if you have one in particular you want to take a look at. Okay, let's just start with one. Let's start with the basic. Okay, so here's the thing. X plus 3 over x minus 2, neither of those are factorable. So my first question, would this have a hole? Okay, how do we know? There you go. Do you want me to help you? There you go. There you go. So nothing cancels. So that means there's no hole. That's one less thing to worry about. Okay. Now, if there is a hole, I'll go back and I'll show you how to go ahead and find that. But let's just go ahead and start going right down the row here. So the x-intercept, well, what was I going to set equal to 0? The numerator. Okay, so set the numerator equal to 0. Well, the only numerator here is x plus 3. So if x plus 3 equals 0, x equals negative 3. Now remember, you want to write this as an ordered pair, so negative 3, 0. Okay. Now, I'm also going to go ahead and have you find the y-intercept. I don't have that on here, so I'll just go ahead and write it out. So the y-intercept. Now, for this one, though, I was going to go ahead and replace all of the x's with what? With 0. So if I'm looking for the y-intercept, you're going to replace all of the x's with 0. Okay, so if I come back over here, well, let's see what that gives me. Up top, that would be a 0 plus 3. Down below, that would be a 0 minus 2. So it looks like I'm going to get a negative 3 halves. Okay, so 0, negative 3 halves. Okay, so I got my x and my y-intercept. And the y-intercept, it's not asking for it, but it's just going to make our graph that much better. Okay. Now let's go to the VA, the vertical asymptotes. What would I set equal to 0 here? The denominator. Okay. So I'll just go ahead and say denominator, set it equal to 0. A little shortcut there. Well, the denominator is x minus 2. There you go. So x equals 2. Now remember, for your asymptotes, you do want to write that as an equation. So x equals, y equals. Okay. Questions on that? Now, for the horizontal asymptote, this is where you had to look at one of those 3 cases. Okay. I'm thinking of a word that started with a D. Degree. Okay, so we're talking about the largest power that any one term had. So I'll get us started. If I'm looking back at the original function, well, the degree of the numerator is 1. Okay, what's the degree of the denominator? It's 1 as well. Okay, so this is a scenario where the numerator's degree equals the denominator. So there is going to be a horizontal asymptote. How do I find it? There you go. If they're the same degree, you go ahead and divide those leading coefficients. Now, we're talking specifically about the coefficients that gave you those degrees. So 1 divided by 1 is 1. So that means that my horizontal asymptote is y equals 1. Now, before we go ahead and move on, once we finish this up and move on to another problem, I'll go back and I'll revisit that. We'll find some where the degrees are different to help you remember those. Okay. Well, the only thing that's left is going to be the domain and range, but typically we do that once we've got it sketched. So let's go ahead and write this out. So the vertical asymptote is at x equals 2. Let me go ahead and do this in something that'll stand out. So x equals 2. So there's the vertical asymptote. The horizontal asymptote is at y equals 1. Okay. Let's see. We had an x-intercept at a -3, so right here. We had the y-intercept at a 0, -3/2, so 0, -1.5. Let's say right here. There was no hole, so let's see. Let's call this region 1, region 2, region 3, and region 4. Why would it have to be 1 and 3? There we go. Okay, because here's the thing. We know for sure it's 3 because that's where I have some intercepts. So I definitely have to go through those. And remember, it's always going to want to get as close to those asymptotes as possible. Okay. Now, for example, it can't be in 2 or 4 because let's say, for example, you believe that it's got to be in 4. Well, if I go ahead and draw a branch here, it has to cross what? It would have to cross the x-axis, and we don't have another x-intercept. So that's telling me it can't be here. Just like in region 2, we only have the one y-intercept, so it can't cross again. So let me go ahead and get this out of the way. The only other place where it can go would have to be region 1. And there we go. Now, for our domain and range, we're going to write those as solution sets. So we have the squiggly bracket, all x such that, and what can x not equal? X cannot equal 2. And then the range, all y such that y cannot equal 1. Remember, those are the asymptotes right there. And that's it. Basically, there are 3 of those questions on your quiz tomorrow. Huh? Just 3. Just 3. That's it. And you know, I got the points spread across. It's going to be okay. It'll be good. Woo, good catch. Okay. So now, let me go back because I want to revisit this very quickly. So if your degrees are the same, well, then you're going to divide those leading coefficients. Okay. Like, for example, if we were to go ahead and take a look at number 2. Okay. So the degree of the numerator is 1. The degree of the denominator is also 1. Remember, we're looking for the largest power that any variable has. So because they're the same, I would divide the coefficients attached to those. So 4 divided by 2, this horizontal asymptote would be at 2. Okay, but let me find ones that are different. Okay, how about 3? So what's the degree of the numerator? 2. What's the degree of the denominator? 1. Okay, so this happens to be where the numerator's degree is larger than the denominator. Yes or no? Now, actually, I don't have to factor because we're not, right now we're just talking about if it's a horizontal or slant. Yes or no, is there a horizontal? Okay, Jackson's saying no. He's absolutely right. If the numerator's degree is larger, there's no horizontal asymptote, but there will be a what? There will be a slant. Okay, so you'll have, I don't know if it's going to be positive or negative, but basically you're going to have a diagonal asymptote. Now, there was a third case here. Let me go ahead and see if I can find one, like number 4. Okay. So the numerator's degree, what is that? 1. What about the denominator? That's 2. So this is the third and final case where the numerator's degree was less than the denominator's. Now, if the numerator's degree is smaller, there is a horizontal asymptote, but it's 0. Y equals 0, the x-axis. Yes. So remember, those were your 3 cases when it came to the horizontal or slant. We just look at the degrees. Okay, does that make sense? Now, I do want to go ahead and take a look at one that has a hole. Now, let me go ahead and show you another example. Now, we're not going to finish up number 2 unless anybody just really wants to do it. But can number 2 be factored? Okay, so we have GCFs here. So if I pull out a 4, that would be x minus 6 over 2 times x minus 2. Well, does this one have a hole, yes or no? No, why not? Nothing cancels. Only if something cancels is there going to be a hole. So let me find one that does. Let's go to number 5. Or actually, we can do number 4. 3 does, but it also has the slant. So I'm not really wanting to take a look at that one too much. So what do you think, 4 or 5? Let's look at 4. Okay. So let's go ahead and factor this. Now the x plus 3 up top, that stays the same. How would I factor x squared minus 9? That's a difference of squares. So we're going to have an x plus 3 and an x minus 3. Okay, so this is one that has an example of a hole. If you've got a group factor that cancels, yes, we're going to have one. Now, even though that group canceled, I'm still going to set it equal to 0. So if x plus 3 is equal to 0, well, then the hole occurs at negative 3. Does anybody remember how to find that y value? There you go. See, once those cancel, would everybody agree all I have left is just 1 over x minus 3? Okay. Well, for every x that's left that didn't cancel, your x value, plug that in. So let's see, 1 over negative 3 minus 3. Looks like it's going to be a negative 1/6. Okay. Oh, did I make a mistake? Okay. I know, it's just crazy for me to ask that. Did Mr. West make a mistake? No one's backing me up here. I feel okay. Maybe we need a joke. Yeah. Where are rainbows sent when they break the law?
I don't get the joke.
Well, I haven't said the answer yet. So where do rainbows go when they break the law? They're sent to prison. You know, some people might think that's a light sentence, but at least it gives the rainbow time to reflect. Oh, somebody stop me. Okay. Those were good. Yeah, they were good. Okay. Now, would you like me to go ahead and find another one with a hole so we can practice that? Do we want to work another problem? So, yeah, okay, let's at least do a hole. So let's take a look at number 5. Okay. How would I factor x squared plus 4x? Oh. So GCF, so I pull out the x. So that's an x plus 4 over. Let's see, I need 2 numbers that'll multiply to give me negative 4, but add to give me 3. So let's see, it's definitely x and x. So we've only got 2 possibilities. We either have 1 and 4, or we got 2 and 2. There we go. So plus 4 minus 1. Because 4 times negative 1, there's our negative 4. Okay, but 4 plus negative 1, there's our positive 3. Okay. So this one has a hole because something cancels. Okay. Remember, only if something cancels do you have a hole. And it is possible for you to have more than one hole. Just at this level, you're only going to have the one. Yeah. Well, let's take a look. So I'm going to take that group, x minus 4 is equal to 0. I'm going to set it solve. So the hole does occur when x is negative 4. So every x that's left, I've got x over x minus 1. I'm going to replace both of these with that negative 4. So negative 4 over negative 4 minus 1. That's a negative 4 over negative 5. So it is 4/5. Right. May. Yes, David. Okay. All right. How are we doing with the rational functions? Do we want to go ahead and fully complete another one of these? We do? Let's do it. Okay. Let's just finish this one. Okay. All right. So this one here, let's see. So we already know that we're going to have x over x minus 1 is all that's left. We've already got the hole. So let's go ahead and locate that. Negative 1, 2, 3, 4. So the hole will be right about here. Negative 4 and then 4/5. So it's almost 1. Okay. All right. So the x-intercept, what was the shortcut? Set the numerator equal to 0. Okay, well, in this case, x, so if x equals 0, okay, so the x-intercept is at 0, 0. Okay, well, that kind of helps me out because what would the y-intercept be? Yeah, this is the one place where both the x and the y-intercept are both the same point. Yeah, so if the x-intercept is 0, 0, y-intercept's got to be the same thing. I mean, even if you want to check it, remember, we're going to replace every x with 0. So this would be 0 divided by 0 minus 1. Well, 0 divided by anything is 0. So yeah, we're still getting the same thing. Okay, what about the vertical asymptote? Ooh, not 0. There's something I said equal to 0. The denominator. Now the numerator gives me the x-intercept. The denominator gives me the vertical asymptote. Well, if x minus 1 equals 0, my vertical asymptote is at 1. Okay. All right, let's look. Horizontal or slant? This one's going to have horizontal. See, the degree up top is 2. The degree down below is 2. So if they're the same, this is when I divide those coefficients. So it looks like my horizontal asymptote is going to be y equals 1. Is everybody okay? Anybody have any questions? All right, well, let's go ahead and sketch this. Let's see here. The x was at 1. So we'll go ahead and drop positive 1 there. We have a 1 here. Okay. Let's say this is 1, 2, 3, 4. Well, absolutely, it's going to be region 3 and also in region 1 again, because we don't have any more x or y intercepts. And remember, even if you're having a hard time figuring out where the branches have to go, you're going to have your what? You still have the calculator. Okay. Now, because this one has a hole, that means we're going to have 2 values listed on the domain and range. So I'm going to go ahead and say the domain is all x such that x cannot equal. I'm going to go ahead and say -4 and 1. Where did I get those 2 numbers from? Remember, you not only have to take the value of x from the hole, but you also have to take the value of x from the vertical asymptote. So the y, you're going to do the same thing. So all values of y such that, what can y not equal? Okay, 1 and 4/5. And there you go. I mean, you got 3 questions like that tomorrow. That's your quiz. Okay, what do you think? Ready to go? That's so exciting. Okay. Did we have any other questions? Okay. Well, let's go ahead and put that to the side. Go ahead and save that. And let's pull out solving rational equations. All right. So I think we got through number 3 yesterday. Okay. Yeah, so first thing we're doing is looking at proportions. This is when one fraction equals another. So let's say I have, A over B is equal to C over D. Well, to solve a proportion, you cross multiply and set the products equal to each other. Okay? It's just another type of equation. You're still looking for, yes, look at that. You're still looking for the value or values of X that are going to make it a true statement. So, anybody else need a copy of the notes? Okay. Go. Anybody else? Okay. Okay. Anybody else? I got plenty. Cool. All right. Well, let's go ahead and look at a couple more of these. Okay, so number 4, it says m plus 3 over 3 equals 8 over m minus 2. Okay, so I'm going to start with the easy one first. Okay, 3 times 8 is what? 24. Well, I'm going to set that equal to, now I'm going to multiply the binomial. So I'm going to do that over here. So I need an m plus 3 times an m minus 2. Okay. Now, does anybody remember how we multiply binomials? There was a little acronym. Started with an F. FOIL, first, outside, inside, last, okay? So let's multiply the first term of each group. So m times m is m squared. Okay, m and m. Let's get crazy. You're welcome. It kept going, okay. Let's go to the outside. So then this would be m times negative 2, so negative 2m. So what would be the inside? There you go. 3 and m, that is a 3m. And then finally the last term of each one, minus 6. So that's going to be an m squared. So negative 2m plus 3m, that's a 1m minus 6. There you go. And see, we ended up with a quadratic. Okay. Sure, when May gets back. So I'm going to go ahead and take this 24. Let's subtract it over. First off, is everybody okay how I got the m squared plus m minus 6? Okay. So this is going to give me 0 equals m squared plus m. Negative 6 minus 24 is a negative 30. Now, I always recommend, when you're dealing with a quadratic, if it's factorable, that is probably the fastest, easiest way to go ahead and solve it. But remember, we have other methods. You could use the quadratic formula. You could complete the square. All are great methods, but I think that's just going to give more work than you really want. What two numbers will multiply to give me negative 30, but had to give me 1? Go. So 0 equals, let me get my two groups ready. So this would be m plus 6. That's supposed to be an m minus 5. And Serenity, do you have your ID? Okay. Here, let's plug in me. Let me change that m back. Okay. Now, you may not remember the name, but how does this help me find my answers? We said each one equal to 0. Okay. So if the first one, m plus 6, equals 0, well, then I got negative 6. And remember, yesterday we were writing these in a little set. So negative 6 and the other one, m minus 5. If m minus 5 equals 0, well, then m equals 1. Plus 5. Now, we really don't have to do so, but would anybody like me to plug one or both of those back in to show you that it's going to work? No. Nobody's interested in that? Okay. Okay. And there was also one other thing we did yesterday that I forgot about when we started the problem. This is just a habit I got into. I just looked, first thing at the denominators, first thing I noticed is that m cannot equal 2. Again, it doesn't really have anything to do with the problem. We're just kind of looking at the big picture answers that we absolutely know can't work. Remember, because we can never divide by 0. Okay, so tell you what, number 5 or number 6? You want to do 6? Okay, let's do 6. All right. So I'm going to go ahead and get us started. So 2 times 3 will give me 6 equals. Now, I need to take 2x minus 3 and multiply that by an x plus 4. Okay, so walk me through this. What would I multiply first? Okay, so 2x times x, that's 2x squared. Now what? 2x times 4, that is a 8x. So that's the outside. What's the inside? Negative 3x, so that's a minus 3x minus 12. Okay, so I have like terms here, so this is going to equal a 2x squared. Should be a plus 5x minus 12. Okay. And now we're going to go ahead, subtract the 6. So 0 equals 2x squared plus 5x, and that would be minus 18. Okay. All right. Now, we've already solved quadratics before. Let me give you about a minute. Find me my solution or solutions to this one. Now, it's not as easy as just saying, okay, what two numbers will multiply to give me negative 18 and add to give me 5 because of this 2 right here. Remember, if you're going to factor this, what method do I like? My father drives red Mercedes convertible. Okay. But remember, there's all kinds of different ways to do that. That's just the method that I prefer. Okay, so let me give you a second. I will tell you that one of your answers is going to be fractional. Okay. Perfect. Okay, we've already got the first right answer. Okay. We like fractions. That puts the fun in function. It's right. You just need to switch the sides. Boom. Correct. Little off. Little off. Because see, remember, once you find the two factors, then you're going to divide by the leading coefficient. Yeah, one of them's got to be a fraction. Little off. Oh, okay. Oh, I got what you did. So you went ahead and divided through after. Is that slip and slide? There's a method that's really similar to my father method that's called slip and slide, and I think it was the division step. But yeah, once you solve those are correct. Okay. All right. So let's take a look. Here is what we should be getting. -9/2 and 2. Okay. So let's run through this real fast. Let's see how we got that. So my father drives a red Mercedes convertible. So the first M was multiply. So what's 2 times -18? Well, that's -36. Now I'm looking for two factors, one negative, one positive. Okay. And I have to add to give me 5. So yes, -9 and 4. I knew it as soon as I wrote it. I got you. All right. So now what do we divide by? Divide by that 2. Okay. Now we're going to reduce. So 9/2, -2/1. Remember, we need to leave it as a fraction. Now we're going to go ahead and move these to create my two binomial factors. We're dealing with x, so I'm going to put that in the denominator, read it from the bottom up. So 0 equals 2x plus 9, and then we have 1x minus 2. And then if I were to go ahead and set each one of these equal to 0, okay, so if 2x plus 9 equals 0, subtract the 9, divide by 2, and then if x minus 2 is equal to 0, there we go. And then, of course, starting at the beginning, x cannot equal -4. All right, how are we doing with rational equations? Okay. No problems. If it's a proportion, cross multiply, solve the resulting equation, we're good to go. Okay. All right, so let's look at the next level. Now these, starting with number 7, they're not going to be proportions. Yes, it's true. You got your back. So here's the thing. You can create a proportion. Like in this particular fraction right here, I've got 4/3 minus 7/n equals 1/6. So you could take the time. You remember when we were adding and subtracting these rational expressions? You could go ahead and combine those on one side to create a proportion, but we're going to go ahead and look at something different. I want to go ahead and talk to you about a least common multiple. I wrote it like that. least common multiple. So we're looking for the smallest number, smallest expression that all of the denominators will evenly divide into. Okay. The goal is to multiply through by one expression that's going to remove all the fractions. I don't want to deal with any fractions. I want to go ahead and just solve the equation. Okay. Now, you're more than welcome. You could just take your denominators here and multiply them together. So what's 3 times n times 6? 18n. So see, 18n is a common multiple, but it's not the smallest or the least common multiple. Okay. 12n works, but again, it's not the least. It would be 6n. Okay. You remember how we went ahead and we were shopping for a common denominator one time? Okay. Basically, it's the same idea. I'm going to take this first one 3. We have the second one n, but this 6 right here, let's rewrite it as 3 times 2. So I'm taking everything from the first denominator. So I'm taking my 3. I'm taking everything from the second one. I'm taking the n. Now remember, as I move through, I'm only going to put something on my list if I need it. Okay. Do I have this 2 yet? Nope. But I do have the 3, so I don't have to add that again. So now 16. But here's the thing. Even if you don't find the least common multiple, are you still going to be able to answer the question? Yeah. Okay. I'm going to actually show you this in 2 different ways. So first, let me go ahead and show this to you. If we multiply through by 6n. Now, sometimes because we're dealing with rational functions, we got a lot of these fractions that are really huge, and we have a lot of variables. Some people can get pretty intimidated by that. So if it helps, go ahead and write it out. Like I would distribute this to each of the terms. So I would first say 4/3 times 6n. Then we have minus 7 over n times 6n equals 1 over 6 times 6n. Now, if you feel comfortable enough, you don't have to do that. Fantastic. Okay. But if you want to make that, sure you have that organization so you don't make a mistake, go for it. Okay. Now, let's go ahead and put these over 1 so we can take a look now. So the 4 and the 1 won't simplify, but the 3 and the 6 will. That'll become 1. That'll become a 2. So what's 4 times 2n? 8n. See, I've removed the fraction. We're going to end up with just a normal everyday equation to solve. Minus. Okay. Well, what can simplify here? The n's. What's 7 times 6? 42. The answer to life, the universe, and everything, absolutely. Equals. And then what's going to cancel over here? The 6's. So the only thing this equals is n. Because the 6 cancel. Mark that off. And see, once you choose your common multiple and you multiply through, you no longer have any fractions, and you got yourself a simple equation. In fact, let's go ahead and subtract the 8n over. Minus 8n. Those are going to cancel. Negative 42 is equal to, what's n minus 8n? Negative 7n. How do I solve that? Let's divide through by negative 7. Okay. So what is n? N is 6. It's not bad. Okay. It's just another way if you're not given a proportion or you don't want to take the time to create a proportion. Multiply through by the least common multiple. Okay. Now remember our answer was n equals 6, right? That's if I use the least one. Well, let's say that you didn't find the least common multiple, that you just multiplied all those together. Let me show you what's going to happen even if I multiply through by 18n. What do you think is going to happen? You're going to get the same result. Yeah. Okay. So this would be 4/3 times 18n minus 7 over n times 18n. You're just going to have bigger numbers. And see, that's why you want to go for the least common multiple, because you're dealing with smaller values. It's going to make your life a lot easier. But that's not to say that it can't be done. And then we have 1/6 times 18n. Okay. Well, let's take a look over here. So 3 and 18 will simplify. That's 1. It'll go into 18, how many times? 6. So what's 4 times 6n? So that's 24n. Minus, well, here only the n's are going to cancel. So I need 18 times 7. 100. Okay, well, you got your calculators. 126. That is not what I want. There we go. 126. I cannot write today. 26 equals, and then what we have here, the 6's, that'd be a 1, that'd be a 3. Yeah, so 1 times 3n is just 3n. All right. Well, now let's subtract the 24n over. Those are going to cancel. So a negative 126 is equal to a negative 21n. What would I divide by? Negative 21. And checking your calculator, that's still going to give you 6. Now remember, even Ridley gave me another multiple. He went ahead and said 12n. Would that work? Yeah, as long as it removes all your fractions, it's going to work out. Now, I do recommend the least one. Yeah, do you have your batch? I do recommend the least common multiple because then you don't have to worry about bigger numbers like this. See, the other numbers were way better. Okay, but it's still going to work. Okay, so let's go ahead and try another one of these. We'll make number 8 our last one today. Okay, so let's see. Anybody think they can tell me? Now, I can definitely just multiply those together and say 2k squared. That will work. Okay, 2k is the least common multiple. Okay. Just think about what we did when we were finding a common denominator. I'm going to take the first denominator, k. Well, the second denominator is a 2. I'm going to take that. But by the time I get to the third, do I already have a k? Yeah, so I don't need it. That's how I got my 2k. All right. So now I'm going to go ahead and multiply through by 2k. As long as whatever you choose is going to get rid of those denominators and get rid of the fractions, you're good. It's going to work. Okay. So let's see. 3 over k times 2k minus 1/2 times 2k equals 12 over k times 2k. All right. So I've got this problem started. Finish it up for me. You should be getting one answer. Okay. It's an integer value, not a fraction or a decimal. Once we're done with this, we are done. Okay. First right answer. Oh, sorry, I'll be right back. Yes, second right answer. Third right answer. Nice. Okay, let me go ahead and start to catch up. What's going to cancel in the first one? So the k's are gone, so that's going to leave me 6 minus. What about the middle product? 2's are gone, so that's just going to be minus k. Okay. Equals. There we go. K's are gone. Sarvation's absolutely right. It's going to give me 24. So negative k is going to equal, well, 24 minus 6 is an 18, but we don't want a negative variable, so I got to divide through by that negative. Negative 18. Okay. How are we doing? Rational equations. Fantastic. All right. We'll finish this